Good day everyone. My name is Mark Robert Deliezo, and for today's report, I will going to report the chapter 15 of the book, which is the geometric design of highway facilities. First, we must know what is geometric design of highway facilities. So, geometric design deals with the dimensioning of the elements of the highways, such as vertical and horizontal curves, cross-section, track, climbing lanes, bicycle paths, and parking facilities. The fundamental objective of geometric design is to produce a smooth, flowing, and safe highway facility and an objective that only can be achieved by providing a consistent design standard that satisfies the characteristic of the driver and the vehicles that use the road. The American Association of State Highway and Transportation Officials, or AASHTO, serves a critical functions in developing guidelines and standards used in highways geometric design. The membership of ASHTO includes representatives from every state highways and transportation department in the US, as well as the Federal Highway Administration, or FHWA. In this chapter, the principle and theories used in the design of horizontal and vertical alignments are presented together with the current standards used from geometric design, as recommended by ASHTO. Design principle and standard are also linked to the characteristic of the driver, pedestrian, vehicles, and road, as discussed in chapter 3. In this chapter, geometric design of highway facilities, it is divided into 7 categories or parts. The first one is factors influencing highway design. Second, design of the highway alignment. Third, special facilities for heavy vehicles on steep grades. Fourth, bicycle facilities. Fifth, parking facilities. The sixth, computer use in geometric design, and the last one is the summary of the 6th part of this chapter. So we're going to the first part, the factors influencing highway design. So, highway design is based on specified design standard and controls which depend on the following roadway system factors. So, there are several factors that can affect the roadway system. So, first, the function classification. The next one is design hourly traffic volume and vehicle mix. Next one, design speed together with design vehicle. Next, cross sections of the highway, such as lane, shoulder, and median. Next, presence of heavy vehicles and steep grades. Next, topography of the area that the highway traverse. Next, level of service. Next one, available funds. Then safety. Then the last one is the social and environmental factors. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factors that can affect the roadway system. So next, we're going to go to the subclasses or the first part of the factor, the highway functional classification highway. So highway function classification highways are classified according to their function in terms of the service they provide. The classification system facilitates a system developed of highways and the locally assignment of highway responsibilities among different jurisdictions. Highways and streets are categorized as rural or urban roads. So in highway and streets, they are categorized as rural or urban roads. Then it is depending on the areas in which they are located. This initial classification is necessarily because urban and rural areas are significantly different characteristics with respect to their type of land use and population density, which in turn influence travel patterns. So tanan depending sa type of land and population density. Then in this part, within the classification of urban and rural, highways are categorized into the following groups. So the highways are also categorized into 5 following groups. The first one is principal arterials. Then the next one is minor arterials. The third one is major collectors, then minor collectors, and the last one is local roads and street. So there are 5 groups of highways. Urban principal arterial system. This system of highways serves the major activity centers of the urban area and consists mainly of the highest traffic volume corridors. It carries a high proportion of the total vehicle miles of travel within the urban, including most trips with an origin or destination within the urban area. The system also serves trips that bypass the Central Business District or CBD of urban area. All controlled access facilities are within the system, although controlled access is not necessarily a condition for a highway to be classified as an urban principal arterial. Highways within this system are further divided into 3 subclasses based mainly on the type of classes accessed to the facility. The first one is interstate. Interstate with fully controlled access and grade separately interchange. Second, expressway. We have controlled access but also include at grades intersection. The third one and the last one, other principal arterials with partial or no controlled access. And this picture is a schematic illustration with a functional process for a suburban road network. So we're going to the urban minor arterial system. Street and highway that interconnect with the argument the urban primary arterials are classified as urban minor arterials. This system serves strips of moderate length and places more emphasis on land access than the primary arterial system. All arterial systems not classified as primary are including in this class. Although highways within this system may serve as local bus route and may connect communities within the urban area, they do not normally go through indefinable neighborhoods. The spacing of minor arterial system is fully developed area is usually not less than 1 miles, but the spacing can be 2 or 3 miles in suburban frames. Urban collector street system. The main purpose of the street within this system is to collect traffic from local street in residential area or in CBD and convey it to the arterial system. Thus, collector street usually go through residential area and facilitate traffic circulation within residential, commercial, and industrial area. Urban local street system. This system consists of all other streets within the urban area that are not included in the tree system described earlier. The primary purpose of this street are to provide access to abutting land and to the collector street through traffic and discharge on the street. Functional system of rural roads, highway facilities outside urban areas comprise the rural road system. These systems are categorized as principal areas, minor arterial, major collectors, minor collectors, and locals. Rural principal arterial system. In this system consists of a network of highways that serves most of the interstate trips and a substantial amount of interstate trips. Virtual all highways trip within urbanized area and a high percentage of strip between small urban areas with population of 25,000 or more are made on this system. The system is further divided into freeways, which are divided highways with fully controlled access and no at-grade intersection, and other principal arterials not classified as freeways. Rural minor arterial system. This system of roads augment the principal arterial system in the formation of a network of roads that connects cities, large towns, and other traffic generators, such as large resorts. Travel speeds on these roads are relatively high, with minimum interference to through movement. So, in this picture is a schematic illustration of a functionally classified rural highway network. Rural collector system. Rural collector system. Highways within this system carry traffic primarily within individual countries, and trip distance are usually shorter than those on the arterial road. This system road is subdivided into major collectors road and minor collectors road. Rural major collector system. Road under this system carry traffic primarily to and from countries, and large cities that are not directly served by the arterial system. The system also carry the main intra-country traffic. Rural minor collector system. This system consists of roads that connect traffic from local roads and convey it into other facilities. One important function of the minor collectors road is that they provide linkage between rural, hinterland, and locally important traffic generators such as small communities. Rural local road system. This system consists of all the roads within the rural area that classified within the other system. This road serve trips of relatively short distance and connect adjacent land with the collector road. Highway design standard. Selection of the appropriate set of geometric design standard is the first step in the design of any highway. This is essential because no single set of geometric standard can be used for all highways. The characteristic of the highway should therefore be considered in selecting the geometric design standard. Design hourly volume. The design hourly volume, or DHV, is the projected hourly volume that is used for design. This volume is usually taken as a percentage of the expected EDT on the highway. So in this picture is a relationship between peak hour and annual average daily traffic on rural highways. So next we have design speed and design vehicle. So we go first to the design speed. Design speed is defined as a selected speed that determine the various geometric figures of the roadway. Design speed depends on the functional classification of the highway, the topography of the area in which the highway is located, and the land use of the adjacent area. For highway design, topography is generally classified into three groups. First, the level, the next is rolling, and the third, mountainous terrain. Then we go to design vehicle. A design vehicle is selected to represent all vehicle on the highway. Its weight, dimensions, and operating characteristics are used to establish the design standard of the highway. The different classes of vehicles are their dimension were discussed in chapter 3. So it is discussed in chapter 3 the different classes of vehicles and their dimension. So we go to next because it's so long. So we have cross-section element. The principal element of the highway cross-section consists of the travel lanes, shoulder, and median. For some multi-lane highways, marginal elements include median and roadside barrier, curbs, gutters, guardrails, sidewalks, and side slope. So in this picture we have two types of highway. First is the figure 15.4, the typical cross-section for two-lane highways. Then the figure 15.5, the typical cross-sections for multiple-lane half section. So this is it, the two figure. Then I go next. We go to the width of travel lanes. So travel lanes width usually vary from 9 to 12 feet. Most arterials have 12 feet travel lanes since the extra cost for construction 12 feet lanes over 10 feet lanes is usually offset by the lower maintenance cost for shoulders and pavement surface, resulting in a reductions of rails concentrations and the pavement edges. On two lanes, two-way rural roads have lane widths of 10 feet or 11 feet may be used, but two factors must be considered when selecting a lane with less than 12 feet width. When pavement surface are less than 22 feet, the crash rate for large truck tends to increase, and as the lane width is reduced from 12 feet, the capacity of a highway significantly decreased. Lane width of 10 feet are therefore used only on low speed facilities. Lanes that are 9 feet wide are used occasionally in urban areas if traffic volume is low and there are extreme right-of-way constraints. So next is shoulders. The shoulder of a pavement cross-section is always contiguous with travel lane so as to provide an area along the highway for vehicles to stop when necessary. In some cases, bicycles are permitted to use the highway shoulder, particularly on rural and collector roads. Shoulder surface range is width from 2 feet on minor roads to 12 feet on the major arterial. Shoulder are also used to literally support the pavement structure. The shoulder width is known as either grade or usable, depending on the sections of the shoulder before considered. The graded shoulder width is the whole width of the shoulder measured from the edges of the travel pavement to the intersections of the shoulder slope and the plane of the side slope. The usable shoulder width is the part of the graded shoulder that can be used accommodately part vehicle. The usable width is the same as the graded width with the side slope is equal to the flatter than 4:1 or 4:1. Horizontal is to vertical, as the shoulder break is usually rounded to a width before 4 feet and 6 feet, thereby increasing the usable width. All shoulders should be flush with the edge of the travel lane and slope of facilitate drainage of surface water of the travel lanes. Recommended slope are 2 to 6% by 4 bituminous and concrete surface shoulder, and 4 to 6% for gravel and crushed rock shoulder.